before I go ahead with a number 6, yeah.
So basically, we can.
Okay, there's quite a bit. I don't like this pop-up thing. I did see this yesterday.
Bit closer, a little bit closer. That is real close right now. There we go. Okay, so we know we are basically at something like this. Something like this. We are really close. Something like 1,000. 1,000K. Okay. All right. So we know that it's somewhere between 999 and 1,000K. Oh, or maybe not. What's going on there? Unhandle exception during user callback. Wait a minute. Oh, ha. That's pretty funny. So we have actually started stack faulting down somewhere else because we gave just enough stack for us to exist. But as soon as we start calling down into Windows, we forced Windows to fault. That is excellent. That is excellent. So we know we have something like a megabyte of stack. That was kind of fun. We know we have something like a megabyte of stack when we enter our first function. If we don't tell the compiler to give us more, I think there is a flag that basically tells the compiler to give us more. If we were to go in here and look at that, we could search for stack, and we would probably find something. Let's see. Force parameters, set stack size /fnum, and I assume that basically if we did a /f, we could have our cake and eat it too. Remember, we cannot make something this big. We tried to make something that big. It was 2 megabytes. Let's go ahead and run that, and that totally faulted. So now let's ask for a giant stack, ladies and gentlemen. Let us just see what we can get away with. Let's do 1024, 4 times 10. What is going on? That is no good. I'm in the wrong mode altogether. There we go, 4 times 1024 times 1024. We will just copy that value. We'll get a nice 4 megabyte stack, in theory. We'll go back in here, and we'll go to the build.bat, and we will do what this thing said to do. Where was that again? Sorry, it was F. Where was that? Where are you, Mr. F? Fnum. So just /f and then that value. Okay, let's do that. -f and that value. And let's see if that gives us a bigger stack. Look at that. We can have all the stack size we want, ladies and gentlemen. That is a very generous stack indeed. Hopefully we will not need anything like that, so I'm going to go ahead and delete that. But just for the sake of completeness, I wanted to show you that we had control over it. All right, I'm going to go into the Q&A a little bit today, just because I wanted to step through these things. And this is basically an entire day, essentially, of Q&A. Maybe we'll let the Q&A run a little bit long if we have to. All right, here we are. We basically clear these things on the stack. We are going to go ahead and initialize our global back buffer. So we're going to call back in here. We're going to pass it a pointer. Now, where is this thing? Where is this global buffer? Well, that's basically something that was created at the initialization of the program. So that's just memory that's not on the stack. That's memory that's permanent. We do not have to worry about it. And you can see that's in a totally different location. Nowhere near the stack, right? If you look at where the window class is, that's very low. And if we look at where this back buffer is, that's very high in memory by comparison. So they're nowhere near each other. And that is kind of what you'd expect, because this is not on the stack. This is data memory of our program, static data memory that was basically created when we launched the executable. Said that we basically said we needed that memory to run. All of our global variables go into it. All right. So we go into resize div section. We are going to allow this call to be called as many times as we want to. So what we do first is we check to see whether we already allocated memory for our buffer. And if we did, we will get rid of it. If we didn't, we basically just fill out a bunch of fields that we will need to remember, the width and the height and the bits per pixel, bytes per pixel, which is things we want to know. And then we are going to go ahead and fill out that information that Windows needed basically to do the blit later on. And you'll notice we have to pass that later on. So that's basically a description to Windows that says we are going to pass you a bunch of memory, and here is how you interpret it. Now remember, we had this negative here. In fact, you know what? I'm going to go ahead and add a comment to that because it's a little confusing to people who don't know what's going on. I'm just going to add a comment there that basically says, note, when the BI height field is negative, this is the clue to Windows to treat this bitmap as top-down, not bottom-up, meaning that the first byte of the image is the top left. I guess I should say the first 3 bytes of the image are the color for the top left pixel in the bitmap, not the bottom left. Right? Make sense? Okay, so that is all that is, and I just wanted to get that out there. All right, recompile that. I haven't really changed any code. So we come back down in here. We basically compute how big we need, because we are going to ask for a permanent chunk of memory. And you may ask, well, why didn't we just do what we did up here? Why don't we just declare the chunk of memory up here? And we could have done that. That is totally valid. The reason I didn't want to do that is because I wanted to make the size of this bitmap be parametric, meaning we could change it at any time in the code. And if we had put it up here, it would have to be known at compile time. We could not change it. We could still do it up there by just doing one that was so big that we knew it was always as big as the biggest one we could possibly ever need. We could totally do that, and maybe we will do that eventually. But for now, I wanted to show you how to use virtualalloc as well. So we went ahead and did virtualalloc, which of course asks the operating system to reserve memory pages for us. It asks us to reserve this many. Basically, however many memory pages it needs to take this much, to hold this much data, to hold this many bytes. And the thing that you have to remember is this will allocate in increments of the page size. The page size, I believe, on Windows is normally 4096 if you are not using large pages, in which case it is 64K. And what that means is we probably will not use exactly the right amount of memory here. We will get back more memory than we needed, just a little bit more than we needed. So if you look here, this is the actual size we're asking for. If I am to go ahead and divide that by 4096 and then multiply it back by 4096, let's see what we get there. Well, that looks like it actually, let's optimize that out. Looks like we are actually right on a page boundary, if that is actually true. Let's double check that just to make sure it's not doing some fancy thing here. So, excuse me. Apologize again for the cold. Okay, this is the size we had. This is the page size that I believe Windows is using. There's a way to get that page size, and we could do that a little bit later too. Maybe we'll do that right now. If that's the page size, then we know we are asking for at least 900 pages, possibly more, and I just wanted to see if 900 pages basically times the page size comes out exact, and it turns out it does. So it turns out we are asking for exactly an even number of page sizes, so we are not wasting any memory, ladies and gentlemen. How about that? Totally accidental. Normally what happens with virtualalloc is you will waste a little bit of memory at the end of it, and so the thing that you typically use virtualalloc for is not to allocate little chunks of memory. You use virtualalloc to get a bunch of memory that you then subdivide, and that's exactly what we'll be doing with it. But right now we only have one allocation in our entire program, so there's really no way we can do anything more optimal there, so we just go ahead and call it. Anyway, we store the bytes per pixel back here, and when we multiply the width times the bytes per pixel to basically get the pitch or the stride, depending on what you want to call that. And basically what that is how many bytes a pointer has to move to go from one row to the next row. And of course, that is the width, the number of pixels across that the bitmap is, times the bytes per pixel, because we need to remember that each pixel itself is actually 4 bytes. Since each pixel is 4 bytes, that means that we could not just go width number of bytes. We have to go width times 4 number of bytes, because we have to skip the R, the G, the B, and the pad for each individual one. All right, so when we finish, we then fill out our window class. Remember, a window class is just something we register with Windows that tells it where to call back when a window needs to actually field a message. We fill out an instance because Windows needs to know who to call as well. So if you imagine, basically, when I talked about the fact that we have a virtual memory address space for our program, right? Well, that virtual memory address space contains our code as well. So if you want to call us back, you have to know which virtual address space you are calling back, right? Windows needs to know which process is actually holding the function, because if I just say, here is the address of a function, well, that address is in my process's virtual memory space. If you didn't know which process you were calling back, you wouldn't know what that address actually refers to, because every address space for every process is different. So a pointer does not uniquely identify memory in the system. It uniquely identifies memory in one process. And so without the process handle, Windows would have no idea who it was even calling. So basically what this is that handle. This is the instance that says this is the actual process that contains this pointer's memory. So interpret this pointer in its address space. And then it can do the dispatch. We give our window class a completely meaningless name because we need to do that, because we are going to pass that name to create window EX, so it knows what window class our window is using. Of course, we only have one, so it's a real waste of time, but that's just something you have to do. We register the class with Windows by passing a pointer to this stack variable that we have here. Now, we don't have to worry about that ever going out of scope because we won't exit this function, but we don't have to worry about it going out of scope, period, because Windows will actually snap a copy of it. It does not rely on our copy, so we don't have to make sure that that copy stays around for as long as we use anything. It is just going to use it to read the memory out, and then it is going to return. And we don't have to worry about keeping it around anymore. You need to remember that sometimes you do. Sometimes when you pass an address into Windows, you have to make sure that the thing you pass.
I'm gonna go to the next day. Just wanted to check if I missed anything.
Looks like the stream begins now, or so says the little timer. And I think we know from experience the timer is never wrong. So, welcome back everyone to Handmade Hero. I hope you have had a good weekend. This week, in our quest to build a complete game from scratch, we are going to be getting some user input and getting sound output working, if all goes according to plan. Not that there is much of a plan, but if all goes according to what we would like to get done. Let's put it that way. So, if you are following along with today's lesson and you have pre-ordered the game on handmadehero.org, you can go to your zip file and unpack the day 5 source code. That is what we are starting with here on day 6. Now, the thing that I want to talk about today is basically how we are going to get input basically from a gamepad, if that makes sense, and also how to get it from the keyboard. So if we take a look here, I'm going to search for something called X input so you can see what I'm talking about. X input is basically the current way that you have to use to get the kind of gamepads that almost everyone actually uses with games now, which are like Xbox 360 controllers. Microsoft, for whatever reason, they introduced their own sort of interface layer for getting controller input. It was called direct input. And then they turned right around a couple years later and decided that they were just going to ignore that entirely and make a whole new one called X input. And so that is what you use now, and they're not even really compatible. X input controllers will show up in direct input, but I guess you can't send rumble messages out to them potentially, and also you can't get the audio handle for outputting audio to the controller's plug, these sorts of things. So if you want to support gamepads properly, you pretty much have to use X input because that's what everyone has. You can go implement direct input if you want to be able to support kind of legacy controllers that maybe don't have an X input driver, but on the whole, you're pretty much going to have to support X input at a minimum. And now what X input looks like, thankfully, it is actually one of the simplest APIs to use on Windows. It is very, very simple. You can actually see, I don't know which one of these has in the MSDN has a good introduction, but I think basically any of these probably has a good, yeah, here you go. So basically all you really have to do is code that looks like this. You loop over the number of controllers that there are, you go ahead and you get the state of each controller, and the state of the controller is basically a big old structure that just has all the stuff that you might want to know about the gamepad. And so it is really absolutely trivial to do, and we will be doing it today. Hopefully we won't hit any snafus, but that is basically it. Now, in the old days, if I remember correctly, you couldn't actually include an X input header file. That's what I want to say. I want to say that was true. But I guess I'm going to assume that maybe that is not true anymore and that we'll be able to sort of directly include it, but I'm not actually sure. So I'm going to go ahead and fire up Emacs, and we're going to see basically what our situation is here in the modern world of programming. So I'm going to go into Handmade. I'm going to launch the trusty Emacs that is, you know, always our trusty editor on every platform. A little bit slow, a little bit aging, but it gets the job done most of the time. And I'm just going to see straight up if I can include, I believe it was xinput.h, because I don't even know if that exists on platforms. And it does. So basically xinput.h holds the definitions of all of the stuff that we actually want to use to get our input. So what we're going to do is we're going to go down here. Now if you remember, we have a game loop. It's really kind of a very beginning of a game loop. I mean, it barely does anything, but we have one nonetheless. We go through here and we process our Windows messages, then we do our rendering, and then we go ahead and blit that rendering to the screen. So what we're going to do is right here after we get our messages, because these are messages that are going to come in to do keyboard as well. A keyboard will come in through here. The X input is a polling-based API, which basically means that it only gives us back the state of the keyboard, the state of the controller when we actually ask for it. So we have to ask for it at some point, and that some point is going to be here, right after we do this. Now, something that we should note, and I'm going to put in a little to-do about this because we may decide that we want to do this later. Should we pull this more frequently? So what you have to understand about input devices is there's two methods of getting input from input devices oftentimes. There's interrupt and polling, sort of a vague way to think about them basically, but an interrupt-based input scheme is one where whenever the controller itself, whenever the thing that you're actually getting input from, the device, the external device, whenever that device actually needs to tell you that something happened, like something changed, a button got pressed, the state of the stick wiggled, something like that, it will actually send you the data, right? So basically it's controlling, in some sense, when you need to wake up and process it. Now that sort of thing doesn't really happen very much anymore, but in the old days that actually used to be literally true. There used to be actual interrupts that would happen on the CPU.
Hey, Headhunter. 69.
That would actually say, hey, this device has something to say. Well, that doesn't really happen very much anymore. For the most part, what happens is things are either pulled or they're kind of a networky sort of thing where they kind of send packets to you and those packets kind of get buffered up or those sorts of things. So in some sense, it's sort of like an interrupt, but instead of actually interrupting you, you're really just reading a stream. Either way, since this API involves us actually polling the X input controller and asking for its state, we may get into a circumstance where we want to pull it more frequently than every frame. Now, I don't know that that's necessarily true. 60 frames a second worth of polling may be plenty, or it may not be. And the only real way to know is by sort of playing with it and testing. There is some stuff we can do inside X input to actually kind of get a feel for how frequently we're polling it relatively to how frequently it would like to be pulled and things like that. But we'll get to that later, because right now we're certainly not going to care about that until we're actually doing the like real serious final stuff for the Windows layer, which we won't do up front. Those will be things we do kind of more towards the end of Handmade Hero. So inside the documentation here, you can see I've got the different functions. You can see that X input is a pretty small API, and that's a pretty good thing, basically. That is what you want. So looking at it, basically X input get state is primarily what we need. Get X input get state is the thing that actually returns the state to us. So all we really have to do is we just have to call this, but we have to call it with this thing called DW user index, which if you look at the documentation here, it says the index of the user's controller. So as you know, Xbox controllers only allow 4 controllers. They've got those little sort of quadrants that they fill in. So there's only 4 that are allowed to be there. But if I remember correctly, there actually is somewhere in here, there is a pound defined that says how many there are. I want to say that is true, but I don't see it listed here. It just says a value from 0 to 3, which is kind of unfortunate. There it is, X user max count. So that documentation was just a little stale. You can see that this is basically the loop that you want here. You go over each of the controllers, and in case they ever increment the number of controllers that are necessary, we know that we would get them all by doing this. So we can just basically use that pound define right there that lets us know. Now, I don't really love I necessarily, so I'm just going to go ahead and say that this is the controller index, just so we know what we're talking about here. And then I'm going to go ahead and expand this out. So there we go. Now we are looping over all the controllers that we might possibly have. And now we are going to pass that controller index, and we are going to ask it to give it back the state of our controller. So this is the state right here, and we pass an address of that thing, and it will fill out that address for us. So there we go. That's basically X input. Now it's going to return to us a piece of information that's whether or not the controller existed, I believe, if I'm not very much in error. So let's take a look. Yeah, controller's not connected. So basically, if it equals error success, you gotta love things like error success. If it equals error success, then that means this controller is plugged in. And if it doesn't equal that, if it equals any other error message, then that means that the controller is not available. Now maybe that could be an error, maybe that could be that it's just not plugged in, but basically what happens is we can't actually do anything with this controller here. So that is actually information that we need. For example, we may want to show in the user interface that a controller has been unplugged. We may want to take action on that. So this is not necessarily just an error case. This is actually a case that we want to handle in the future. Right now we don't need to because we don't have any logic, but in the future we may want we want to handle that. Okay, so all we're going to do here is we're going to actually look at this controller state, right? We're going to take a look at the sort of things that we can get in it. And if we go in here, I guess, let's see if I've got a good, where's a good, there it is, X input get state. So you can see what it's got here. It basically has a packet number. And again, remember when I was saying just a few minutes ago, I said that basically there's a concept of the device sending you pieces of information perhaps, or being pulled at a certain frequency and that sort of stuff. Well, this packet number is basically sort of increments every time we know about the state of the joystick changing. Now, I don't really know, since I don't know the internals of how X input works, I don't know whether it's the driver that's thinking about that, so that the driver internally is polling it more frequently and incrementing that, or whether the controller itself actually manages that. I suspect it might be the controller. I'm not really sure. Doesn't matter either way. Point being, when we pull the state, we get back a number that basically says what where we are in the series of state changes for this particular controller. So if we missed a bunch, if we pull it and it says 5, and we pull it again and it says 30, we know that there's a bunch of states that the controller went through, maybe buttons that got pushed or the stick got twiddled, that we never actually saw. And that would be an indication that we might be pulling it too infrequently. Now, it doesn't necessarily mean that, because it may be that it just gets sampled at a really high rate and we don't actually care about that because the user can't actually press and unpress the button at a rate that's that fast, or things like this. So we don't actually know, but at least it'll give us a little bit of an sort of an informational boost, right? So basically all we're going to do here is we're going to say, okay, the controller, when we get it back, we're going to get that thing. So in the future, maybe we'll take a look at that. I'm gonna say that DW packet number, I'm going to actually write that in here as a thing to maybe look at, see if packet number increments too rapidly. And then we're going to look at basically this gamepad piece. So I'm going to snap a pointer off of this thing so we don't have to keep talking about controllers state dot gamepad. I'm going to actually grab X input gamepad star pad equals the address of that. And that's just syntactic convenience, so we can just talk about it like this. So the X input gamepad is the only structure we've got defined currently. As you can see, it's got a bunch of fields that correspond to the things on an Xbox gamepad. Shocking, I know, but that is all that happens. So W buttons is basically a bit field. You know those bit fields. Again, I think it's funny because people in the Intro to C stream were asking how often you do bit manipulation, and I'm like, we do it all the time, and man, we have done it a lot, and all we're doing is implementing the Windows layer, right? We've already done a ton. So that W buttons field, it's basically an ORed together version of these fields right here. Now it's a word, which means 16-bit. That's Windows for 16-bit value. Byte, 8-bit value, 8-bit value. Short, 16-bit signed, right? So we've got the buttons, and the buttons include the D-pad. Those are considered buttons, actually, since they can either, I don't actually know why they're buttons, because they're mutually exclusive. You can't really press the D-pad like left and right buttons at the same time, but there you go. That's how they work. We've got the start, back, the thumb buttons, like when you press them down, the shoulder buttons. You got the A, B, X, and Y. And then you've also got, on these things, the triggers are analog, so you know how far the user pressed them down. So those are actually bytes that range from 0 to 255, depending on how pressed they are. And then you've also got two XYs for the two thumbsticks, the left and right thumbstick. So, it's real self-explanatory. There's almost nothing that you really need to learn here. I mean, it should be real self-explanatory. I'm going to take a little almond milk hit, and then we're going to take a look at these. Okay, so basically what we're going to do here is we just want these things, out. And the question of what sort of stuff I actually want to get for this game, this game is kind of an old school game, so I suspect that mostly what we're going to be looking at is those 4 buttons, as I really don't know that we're going to want to do much other than the 4 buttons. And maybe the 2 shoulders, yeah, like the 2 shoulders, these buttons, maybe the start and end, I don't know. The D-pad. I'm thinking most of the stuff we want in here. Triggers is probably not going to be very useful for an old school game. I don't suspect, because, if you were playing an old SNES game or something like that, you probably didn't have a lot of like first-person shooting or that sort of stuff. So I don't know that those will be very useful. And these, well, I don't know. It depends on whether we want to. The reason to support these guys, even though we're probably not going to want them as much for an old school game, is that Well, I think we all know the Xbox 360 Gamepad's D-pad was not that great. So if you're talking about the Xbox One, you could probably play on the D-pad and be very happy, but we may need to support the thumbsticks just because that D-pad on the 360 was so bad. So it looks like most of the stuff we're actually going to want. We don't actually need to do anything with it yet because we don't have much defined, but basically what we're going to do is we're just going to go in here and sort of mark out the stuff that we actually care about. So we care about these things. We care about basically whether this is down. So I'm just going to kind of line these up here, and then we'll take a look at them as we go. So let's just take all the things that we need. So we want D-pad up, we want down, we want left, we want right. We kind of want to see these things. We want start and back. That's good. We're going to want left thumb and right thumb, left thumb and right thumb. And we are going to want A, B, X, and Y, I think. Oh, not thumb. We're going to want shoulder. We don't actually want thumb. I don't think we want thumb. Thumb is always hard to press for me. A, B, X, Y. There we go. Okay, so we've got up, down, left, right, start, back, shoulder, left shoulder, right shoulder, A, B, X, and Y. So I guess we'll call these A button, just to be clear about what that is. There we go. So that would basically decrypt into Booleans, right? All the things we might want. I don't think we want those triggers, but we are going to want that left thumb, I think. We're going to want that left thumbstick. So we're also going to want here something that's basically the int16 of the, I guess the stick left, what should I say? Stick horizontal, I guess would be it, or stick X maybe, let's call it, and stick Y are the two things that we are going to want. So we're going to want to grab those out of the pad as well. S thumb LX and S thumb LY. Now the question of whether we want the right thumbstick or not, I think we're going to need those buttons, so no one's really going to be able to use it, so we can just leave it there. So that is basically, as far as I know, I'm trying to remember if there's anything else that we actually need. What did I do here? Oops, that D-pad's not supposed to be there. I'm trying to think if there's anything else we need. I didn't bother to delete the D-pad part of this, which is kind of a mistake. There we go. I'm trying to think if there's anything we actually need, but I don't think there really is. That's probably all we need to get out of these. And we're going to get them for each of the 4 controllers. Now we'll have to decide whether we actually need multiple controllers in the future, but that's basically what we're doing there. And the thing that you'll have to notice now is that X input get state is again something that we have to link with. Now, there's a little bit of a complication here. And I was trying to decide whether I wanted to handle this today or handle this in the future. And I think based on the time that we've got here, I think I probably want to handle it today. That's my thought because we've got a lot of time. And it's not that much work to get that X input get state. So you'll note that we've got what we had many times before here. Unresolved external symbol, X input get state, referenced function, win main, right? And so basically that's exactly what we were talking about before. And as you know, I taught you what to do in this circumstance. You basically just need to look at the function, wherever that function is. And inside that function, it's going to have a thing down at the bottom of the MSDN documentation that will tell you what you need to link with. So you can see it here, and it's got it, right? Now, the problem that you will see is, you know, it's got it here. It's got some stuff listed, right? What's the DLL? Oh, it's 1.4 or something, blah, 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 right? The problem that we have is that this platform requirements line is a little bit sketchy, right? It's like, okay, it requires Windows 8, potentially, which we know that most people don't have because nobody wanted it, right? So that's not happening. DirectX XDK, well, we don't really know what that means. What version of it do they mean? And, you know, does the user have that installed? I don't know. We haven't actually used anything from the DirectX SDK, but when we do, we'll probably use one from a very early version of the DirectX SDK, basically. So we can't really guarantee that that's going to be on there. And Windows Vista, well, what if the person was running Windows XP? I don't know. I don't know why Windows 7 isn't listed here. Presumably if it was in Vista, it would work on 7, but I don't know. So you can see that it makes me a little nervous. So what I would rather not do is I'd rather not link directly to xinputlib. Because if we link directly to xinput.lib, then what's going to happen is if it can't find one of these DLLs on the system, then our game just won't load. Just flat out won't load. And that's kind of annoying because you don't need a gamepad to play this game. We're going to allow you to play it with the keyboard at a very minimum. And so it would kind of be bad if you couldn't launch the game due to X input when you otherwise could have totally easily played it with a keyboard in the circumstance where there wasn't an X input library. So what do? How do we resolve this external symbol problem? Well, what I wanted to introduce you to was the concept of basically loading Windows functions yourself, essentially. Basically getting the code into your executable for a Windows binding and looking up the function pointer so that you can actually call directly into it without using an import library. And this is actually a really simple process, and especially in a circumstance where we have such a small number of functions that we actually need to deal with. In this case, possibly only 2 that we might need to deal with total. I'm looking here. Let's see. What is X input enable? Do we need to call this? Let's see. In response to get input state, state will be registered but not sent to the device. I don't know if we need that one, but pretty much we're going to need get state and set state is probably mostly all we're going to need, because set state allows us to send vibration out, and we may want to vibrate the controller in response to things. That kind of adds a little bit of fun to a game. So we may want set state as well, but that's really all we're going to need is X input set state and X input get state. So what I want to do is basically I want to kind of come in here, and I don't know if I don't actually know how good the browsing is. Oops, I'm going to open up devenv and get back to our program in the debugger. I don't actually know how good this is. Can this do a open document and jump us to it? Let's take a look. Hello Windows. There it is. Good job. Okay, so basically we're looking at this, and it looks like it wants xinput 1.4.dll, and that's fine. You can see it defines those here for us if we want to know them. And then you got all the defines in this Windows include header file that basically are all the things we were looking at, right? It's got this one, it's got that. And then this is the part we actually care about here. It has the defines for these 2 things, right? These are the 2 functions we actually care about. And so what I'm going to do is I'm going to say that we're just going to flat out get these ourselves. We're going to load them ourselves from that DLL without actually asking Windows executable loader to do any of it. So what I'm going to do is I'm going to cut and paste the definitions in here, right? And I'm going to strip out those little in and out annotations, right? Because those are just for the static code analyzer, and we don't actually need those. I'm going to get rid of all this stuff so that we just have the function signature, and that's it, right? You can kind of see it just got the function signature, nothing else in there. Going to get the function signature for this one as well, right? Like that. And go in here and make sure I've got the vibration one there as well. There you go. So now I've got the 2 function signatures. Now what I'm going to do, as you know, if I just put the function signatures in like that, then basically what that's just telling Windows is, hey, by the way, there is an external function somewhere called this, in case you didn't know, and now if I call it, you can bind to it in the linker stage, right? So that doesn't help us because that was already in xinput.h, so that does absolutely nothing for us. But what I can do is, instead of actually treating it like this, I can change this into, oops, didn't mean to hit that. I can change this into a type def. I can basically say, I am going to do a type def that tells the compiler there is a function of this type, and I want to actually start declaring variables that are pointers to it, basically, right? So this is actually saying I just want a type called xinput_getState, right? This is the name. I want a type that basically is a function. That's the type of this thing. So you know how you say type def int foo, and now foo is basically a synonym for int. So if I do foo x, I've got an int. Well, if I do this now, if I have xinput_state as my type, if I say xinput_state foo, well, that doesn't really help me because you can't define actual objects that are functions in C, so that's not going to fly. But what does fly is if I wanted a pointer to one of those functions, I can do this. I can basically declare a pointer to a function that has this signature. And that's totally legal, and that's exactly what we want. So, what I'm actually going to do is I'm going to go ahead and say that this is a global variable, since there's only going to be one of them. We are going to have xinput_getState and xinput_setState, xinput_getState and xinput_setState, like that. And the problem now is we're going to conflict with this Windows header file if we call them the same thing. As you can see here, right, they've defined these. They're not macros or anything. We can't really undefine them. I could not pound include this file, but then I would lose all of these defines that they did for me. I'd have to cut and paste them in. That might be something that I might want to do, but for now, I don't think I want to do that. So we're just going to go ahead and say, well, all right, maybe dynamic or something like that. I don't know. I'm not sure what the right was. Let's just dy. We'll just prefix it with dy. So we know this is our dynamically loaded one, and that is what it will be from now on. In fact, you know what we could do? We could do something even cleverer. This may be a little bit too clever for our own good. I don't know if that's actually true or not. Sometimes, but let's find out. What we could do is we could say, okay, let's stick an underscore after them just so we know, and then we'll actually just go ahead and change what the meaning is right here. We could do that. It might actually work. I don't know. Let's see. Let's get wild on a Monday. This basically says, all right, from now on, anytime you see this, change it into this. That way we can still use the real name, but it will always actually remap to our fake pointer. Yeah? Make sense? Hopefully that's clear enough. I'm just making that a little bit more easy because I don't want somebody typing x input get state in here and calling the Windows function because we're not linking with that. Of course, they would get a link time error, but I don't know. I'd like to try and prevent people from accidentally doing that. So maybe we just do this, and that's good enough. Okay, so let's recompile that. Off we go. And so now what will happen is you'll notice that we have a call to x input get state, and it's down here, right? That is now defined to actually be this, so it's going to actually call the function pointed to by our pointer, but our pointer is uninitialized, right? It's 0. It's not initialized, it's 0 because it's one of those static global variables. It's 0. So basically what will happen is if we run this program, we will just flat out crash. At least I assume we will. Let's verify that. Yes, we will just flat out crash, and the kind of crash we will have is basically an execution violation. So you remember, we've seen what happens when we try to read and write from invalid memory. We get an access violation. Well, you also get the same kind of access violation if you try to execute memory that isn't valid. And that is exactly what's going on here. Basically what's going on here is we declared a pointer to a function. We did not point at anything, and then we went ahead and tried to call that function. Well, unsurprisingly, that jumped to 0, 0, 0, 0, 0, 0, 0, as you might expect, and there isn't anything there. So it immediately faulted and stopped our application. So that's fine, but what we do need to do is we do need to basically figure out some way of actually pointing this to something useful. So how are we going to do that? Well, the way we're going to do that is twofold. First of all, and I mean, we kind of have two choices here. I'm going to show you how to do one of them, and I'll briefly mention the other. But the first thing I'm going to do is I want to go ahead and stop this thing from crashing in the case where we don't have these pointers. So I'm going to take I'm going to take the ridiculousness up one more level and basically define a macro. This is how I normally do things. This is how I normally do them. I know it's particularly odd. But basically, I'm going to define a macro that defines a function of this form. So basically, it looks like this, right? It is a macro that just outputs that, and oops, I don't know why I keep hitting the insert button today. So basically, if you run this macro and you pass it a parameter, it will basically define for you a function with that name. That is all it's going to do. And then I can replace, and well, I can do the other one as well while we're at it, right? Y input, oops, not Y input, X input set state name. There we go. That's the other one right there, right? Looks good. Oops, got rid of the D word. Didn't mean to do that. There we go. Got everything in there. And looks right. Okay. So basically what we're going to do is we're going to define these two macros that basically define the functions for us. We are then going to define our type def in terms of the macro. So we're basically going to say, well, that's just this, right? That, you can see, this line will now produce this line. So we can get rid of it, right? Same thing again for the set state one. We want to produce this line, so we'll just do x input set state. Oops, just the G there. X input set state. That'll produce this line for us. And then the global variables can stay as they are. Those totally work. And now you may wonder, and then we've got our remapping down there. Now you may wonder, why did I bother doing that? Why did I bother breaking it up in two lines? Well, it's because I want to make functions of this form as stubs, basically, right? So we've defined the types, but I want to actually do an x input get state stub, which is a function with the same signature, but that does absolutely nothing, just returns 0. That's it. And the same for set state. There it goes. Now I'm going to say x input get state stub and x input set state stub. There we go. Let's compile that, make sure everything's cool, and it is. So I hope you can see what I did there. Basically, this is a very efficient way of defining the function prototype once for the thing you want, defining a type of that so that you can use it from now on as a pointer, and we want to be able to do that, defining a stub with it as well, and now if we need to change this function signature at any time, it'll change it everywhere, right? So it's kind of nice and compressed in that way. Now the stubs, and I might go ahead and do them like this, right? In fact, I might even go a little bit further and say just group these all together by set state or get state. So there's that one and there's this one, right? Yeah, makes sense? So basically, these are our definitions now. This is our support for x input get state, and this is our support for x input set state, right? And all I've done is I've made it so that now our function pointers point to a default function right off the bat. So in theory, now when we run, we will not crash, we'll just do what we used to do. And what will happen is, and we'll see here if I run to it, basically what will happen is this function pointer is just pointing at the stub function, so when we jump into it, we just jump to our stub function, right? No harm done. So basically, that's a good way to initialize your function pointers, to just point to a stub so that if you don't initialize them ever again or fail to be able to load the thing you're going to load, well, it's no big deal. So let's go ahead and call that done for now. And now we got to see how to actually load the Windows versions of those, right? Pretty straightforward. So I'll just reorganize that a little bit here. So I'm going to make a function up here just because I want to be able to keep this close at hand. I want to be close to these definitions so I can just see it easier, to be honest. We're going to call internal here, and I've got these, yeah, I got internal, right? Good. Why isn't these should all be called internal. I don't know why they're not, so I'm going to go ahead and do that just to make sure. Yeah, these should all be internal, and they are. Okay. Okay. In fact, wait, but isn't this one, can't this one be internal too? Is that allowed to be internal? Any complaints there? No, it's not, because it's a... Yeah, okay, good. Okay, sorry about that, just a quick... When I see something in the code, sometimes I'm obsessively going to have to go touch it. That's just the way it goes sometimes. All right, so I'm going to go ahead and define the new function here called load x input. And I guess we'll prefix it with win32 since that's what we've been doing. Load x input is just going to be a thing which tries to get x input if it can. If it can't, it can't. No big deal, not a problem. All right, so what we're going to do is we're going to essentially do...
Hey, Yakuza Plazy. Is it worth to buy a MacBook Air M2 for software engineer? I don't know. I don't think you need one to do development. It depends on what kind of software you develop. I mean, if you want to build iOS apps or do something with Swift, I guess you need it. But otherwise, I don't know. I mean, it's up to you, really. I don't think you need it. I've never had one.
The steps that the Windows loader does when it loads our program. So, we are going to use a function called load library, which loads basically the DLL, the backing part of a...
I'm from India.
The thing that Windows uses basically to give us functions, which maybe, and we're going to have time in this stream, I think. We're going pretty good here. I might actually draw some diagrams for this one so you can kind of see what it is. We're going to use that to load the DLL that we actually wanted. So we're going to call load library with a file name. The file name is going to go in here, right? And that's going to give us back a module, which is basically a handle to some code, right? A handle to a loaded piece of code, kind of like our H instance was in WinMain, if you remember that. It's that sort of thing. So what we're going to do is get the X input library. We're going to load it, and assuming that we get back a valid library, we're then going to load the functions out of it. So X input get state our function here, get state, is going to be equal to something that we load out of that library. And our, I always want to type Y if I type X. Set state is also going to be 1. Now the function that we need for that is called getProcAddress, and we'll see how that works in a second. So load library, we need a file name to load, and remember, I was mentioning it before, inside that xinput.h, they actually were nice enough to define for us, for this version of the header file that we're using, which one it is. But to be honest with you, I would rather use the earlier version because that would give us a little.
Just confused between Windows or MacBook. I mean, I don't think I can answer that question because I don't use either. But yeah, I mean, it would depend what kind of development you need to do. If you want to build games, I would say Windows better. Oh, nice to meet you, Yakuza. I'm from Kerala.
More compatibility. Now I happen to know that xinput 1.3 tends to be available on a lot of machines, so I'm going to go ahead and just verify that guy is there. So let's take a look. Let's go ahead and change over here to Windows, and let's do a dir/s. I don't even know if this command works anymore like this, but let's take, oops, that's not good, .dll. I just want to see if it has one of these still there. Sure does. Yep. Does it have before? I don't know. Let's find out. Let's take a look. What DLL bingo, ladies and gentlemen, what DLLs do we have? Definitely got xinput 1.3. We got 2 copies of them because you can always do with a few more copies. I think one of them's a 64-bit and one's a 32-bit maybe. I don't know. You can see these is in WoW32 and this is in System32, which I think means this is the 64-bit one and this is the 32-bit one, paradoxically perhaps, or yeah, okay. So if we were to try and load xinput 1.4, we would not even run on this machine probably. So basically this just kind of gets back to what I was saying about why you kind of want to take this sort of thing into your own hands potentially. Let's if we were to actually let it load it for us, it probably would have failed. So I'm going to try and load xinput 1.3 instead of 1.4 because that's going to be on more machines, and that'll mean you don't have to install a bunch of stuff to actually have our game work. So assuming we get that back, I don't know if you have to check for invalid handle value. What is it? Is null, so that's fine. So basically, we're going to load that DLL up. It's going to map it into our process virtual address space. We are then going to pass that handle.
I want to work in Gen AI or machine learning module. I don't know. I mean, I think you should ask someone who already does that. I have no idea about any of it. Well, I don't think it matters either ways, if it's a Windows or a MacBook. Because I'm guessing you'll use, I don't know what you'll use. So actually, yeah, you should ask someone who does.
To a function called getProcAddress. And what getProcAddress does is exactly what it says. It gets the address of a procedure or a function. So if we look at that, basically all we have to do is pass the module and then pass the name of the thing that we're trying to load. So we are trying to load xinput getState and xinput setState. Now you will notice, since it does not know, getProcAddress does not know what the function signature is that it's loading. It can load anything, any kind of function. It's just going to return what is basically a void star. So we are going to have to cast the return of this to the type that we actually want, otherwise C will immediately complain. And we know the kind that we want, so that's pretty easy. We just do it like this, get input set state star, and that is that. So we're going to go ahead and compile that, and we're going to go ahead and see if that worked by stepping into it and taking a look at sort of what actually.
Get proc. What does it do? Retrieves the address of an exported function. Oh, interesting.
Actually occurs, whether we get valid function pointers back from those. Oops. Of course, that'll only work if we call the function. If we never call the function, we're not going to get much help, I suppose. So that's kind of initialization stuff. So I'm going to just put that right here. First thing we do, we're going to try and load it. If we can, we can. If we can't, we can't. So let's go ahead and see. Can we load it? Loaded just fine, looks like. So we go in here. We'll call get proc address. Did we get an address for that? Let's see. X input get state. What happened there? Oh, right. It's an underscore. Sorry. And X input set state. We use that macro trick. Makes things a little more complicated in the debugger. It's true. So it looks like we got both of them. And you can kind of see now if you look in the watch window, it's kind of interesting. The watch window is actually smart enough to tell us that these are now pointers into the X input 1.3 DLL portion of our memory space, right? Which is kind of cool. So we've got them now. Let's see if we can run with them. We can. And so in theory now we are actually getting back from Windows the actual state of the controller, which means if we wanted to, for example, we could make it so that something was predicated on that. We could make it so, for example, that we do this little thing here, like we add Y offset. Maybe we will only add Y offset if one of these is down, right? Since this is just our little thing that we play with anyway. Maybe we'll go in here and say, well, if the A button is down, right, let's add to that, right? And there we go. Now, if we're running, we should see no actual Y motion, and that's true. And if we had a gamepad here, which you know what? I don't see any reason not to run into the other room and get a gamepad and test this out. I don't really think there's almost any chance that there's anything wrong. It's such a simple API, but you know what? Give me 1 second. I'm going to go grab one. Plugged in my TV.
While he looks for the gamepad, I'm gonna go get some coffee. Perfect.
Seems worth it. I don't know. Only took a couple seconds. You can see I've even got the one that was sort of the video, and I actually don't think that's true. The one I recorded in the trailer is actually at work. I got 2 of these pink ones. I bought them one time. I bought 2 pink ones and like a green one. They were all they had left at the Target downtown. We were trying to play a game called Gang Beasts, and we wanted extra controllers. So let's take a look and see. I don't know if this is going to work here. It doesn't look too promising because it's not actually lighting up for me, which does not fill me with much hope for the fact that it's actually working properly. But what are you going to do? Let me try plugging it into the actual PC down here. Ah, there we go. That had a little light flash on it. I don't know. That might indicate something good. Not actually sure. Well, yeah. Well, I don't know. I tried. Let's see if we can get this gamepad working. This doesn't seem like it's going to be much to do with... Oh! No, that actually does. There we go. Okay. Totally good. I guess it just
Awesome.
have to... I don't know. I don't know why the light... You can see the light just came on. I don't know why the light wasn't actually on originally. I thought that it would just be on when I plugged it in. But maybe you actually... It might be that you have to actually load X input for it to actually go on or something sometimes on older versions. I don't know. Normally when you just plug it in, it just works. But I guess because this machine perhaps doesn't actually have the little X input helper, the little X box controller app or whatever, maybe it doesn't. But that's pretty good. That was it for controller support. I mean, you saw that was like hardly any code, right? And we did it the hard way. We did it loading it ourselves. But you can see, I don't know if you can see there, when I push the button, it totally works. So we're basically done. I mean, that's the controller input. There is nothing else to it. We can go ahead and send Rumble back to it, so I guess we might as well. I don't know what else to say about it other than, hey, that when you actually make a good API, ladies and gentlemen, which X input actually isn't that bad. It's got a few things that are kind of annoying, but on the whole, it's pretty easy. Look at how easy it is for people to program, you know? It's a good thing. So I guess what I could do here is just call get X input set state just to verify that it sort of worked. I could go ahead and just send that to the 0th controller. Yeah, and we'll just send some Rumble level out to it just to verify that it's actually working, and then we'll save that for some other time later when we actually have some really coherent thing that we want to do with it. So I'm going to go ahead and look up X input set state here just so I can see what the parameters.
I'm gonna skip ahead because don't really have a controller to test. Let's go to the milk kit.
And we might as well do it. But in the meantime, there's basically sys key downs and sys key ups. Let's see, sys key up, and there's key down and key up. I think that's basically it. And I'm not sure, I don't remember these at all, so we're going to look at them. I don't even get input this way anymore. Like I said, I usually use the kind it's significantly a little more complicated, I would say, but you get a little bit more from it, so it's something we'll kind of cover more in the future. But you definitely don't want to start with it because it's a bunch of complexity that you don't need for anything other than if you actually want to handle multiple keyboards. So let's take a look here. So in sys key down, the W param is the virtual key code. And the virtual key code is basically the thing we want. So what Windows is going to do is Windows is going to call us back with these messages whenever anything happens on the keyboard. Now, you don't need to register anything. It just happens. Windows will always send these to you. And normally what was happening before is they were going into here. They were just getting eaten up by the def window proc. So all we're going to do is start actually looking for them. That's it. So basically, the W param is the virtual key code. The W param is the thing that comes in here. It's just an anonymous parameter that depends on what message you have. So the virtual key code is this. So let's go ahead and mark that off. Is that true as well in sys key up? Let's see. Sys key up. Yep, it is. Let's look at key down. And key down message. Let's take a look at that. The virtual code of the non-system key. Yeah, so basically it always is going to come in with the VK code there. So that is exactly what we wanted. We want our VK code. Now I'll tell you what a VK code is in a minute. But for now, suffice to say, it's just a thing which tells you which key it was. But there's also this other thing, which is the L param. And the L param basically tells you some additional things about the what went down, basically. And so there's the previous key state, which is bit 30, right? So if you shift 1 up by 30, you get bit 30. If we take a look at L param ANDed with that, that tells us whether the key was down before the message was sent or up before the message was sent. And so I don't know why you would receive key down messages if the key was already down, but it may be because of key repeat, if that makes sense. Like, you hold down a key, like this, and it keeps going. I think that might be the case, and we'll double check that. But for now, let's go ahead and just say, okay, no matter what happens, we're going to get basically a VK code out of it. We're going to see what the W param is. That tells us what key actually went down, and we're just going to look for the keys that we actually want. That's all we're going to do. We're going to take a look for those individual keys, and the keys that I actually want basically are VK. I think these are the way that they are listed. I'm going to see if there's actually a VK code listing somewhere. Let's see, VK code listing. Because I don't remember what they all actually are, because they have different names sometimes. So you can see, all right, so here you go in MSDN. There's a listing of all of the VK codes. And the VK codes are basically all of the codes that don't have direct ANSI mappings. So basically, you remember the ANSI key code stuff we talked about in the Intro to C stream? Well, basically, all of the ANSI keys actually map to their actual ANSI equivalents, right? So if you actually in C, if we wanted to, let's say, test for the W button, you could actually just do that, and it would work. At least I believe it is always the capital. Yeah, it maps to the capital, if I'm correct, if I remember correctly. Yeah, that is the W key, and we'll double check this to make sure it wasn't the lowercase, and I'm totally wrong. Well, you know what? We can just do it right now. Output debug string A, W. Very exciting. All right, let's go ahead and run this. And get this window over to the side there. Where's our output? There's our output. W, there it is. You can kind of see it Wing out there. Always good. So that's all we really needed for any of those. So if we want WASDF, basically what we're looking at is just something like this. Really, really trivial code here. Nothing particularly interesting. So if we want the full complement, let's say WASDF S, D, and of course the ubiquitous Q and E. You always need those special options. That is basically that. Nothing particularly interesting there. And then we just need to know stuff like, say, the arrow keys, maybe the space bar, and then probably like escape. That's kind of the stuff that we would expect to get back in a game situation. I think that'd probably be pretty good for now. So we've got Q and E, and then we go in here, we're going to need VK up, VK left, VK down, VK right, VK escape. Is it escape or just esc? I wonder. I don't actually know. Let's take a look here. You can see these left, up, right, down. There's home and end and all these other good things. VK escape. So it is escape fully typed out. And then what else did I say? Space bar is a typical one. Is the space bar mapped to just space, or does it have an actual space in it? VK space. There we go. So that's it. That's basically all there is. And those are all the key codes that we might want to handle. Now, what we're going to do with those is going to be determined once we actually get our game stuff working and we have a place to wire input up to. But I just wanted to show you, so that there was no confusion, basically what was going on. And so we can also get some more information here. Like I said, this is going to be basically a was down, which is basically saying, oh, okay, was the key down beforehand? So that's like if this is not equal to 0, then the key was down. I'm basically just turning that into a guaranteed Boolean. This bears a little explanation. Again, this has been a pretty good stream in terms of having plenty of time to talk about stuff, so I'm just going to say what I'm doing here. So basically this L param is a bit field. It's got a bunch of bits set. It said that the 30th bit tells us whether or not the key used to be down or used to be up before this message, before whatever key event triggered this message. Well, if I just and those together, then what I'm going to get is I'm not going to get 0 or 1. I'm going to get 0 or bit 30 being set, which is way not 1. And since I wanted to sanitize it into a 0 and 1 potentially, since I was going to put it in a bool, I don't know. I don't really have to put it in a bool for any particular reason. We'll talk about that kind of a little later on maybe. Maybe we'll even talk about that tonight since we got extra time. I just said not equal to 0. That comparison, if you remember from the intro to C stream, we were talking about it, and I think I was actually even a little unsure about it at the time, which is kind of odd considering the fact that I would have known that this happened, but what are you going to do? Sometimes when you're on stream, you're a little crazy. Basically what happens is if you ask C to do a comparison for you, it will produce 0 or 1. So if we do not equal to 0, that will actually produce a 0 or a 1, depending on whether it was a 0 or the bit 30. So that's basically just turning, it's basically turning, this, we got back either this or 0, right? We got either that or this. But what we wanted was this or that, right? We wanted this one to turn into 1 and this one to turn into 0. And so the not equal to 0 just basically forces that to happen, right? That's about it. All right, so that's a was down, and then I also want an is down, meaning what actually was this message trying to tell us. And so let's take a look at back to the WM key down message, and what does that actually say? Okay, the transition state, what is the transition state defined to be? Always 0 for a key down message. So what is the key up message? Is it always that as well? Always 1. All right, so the transition state, so basically the other bit will tell us what it actually is now. So basically if that bit is set, am I correct? For a key up message, it's always 1. So we want it to be equal to 0 if it's down now. Is that correct? Because key up, yeah. So let's take a look. Basically, I'll go ahead and test this with, say, the escape key. So when we put that, I'll do an output debug string, and I'll just do a test on is down, right? Let's see. Do it this way. And was down, right? So we'll do output debug string escape, and then we'll say is down, was down. Excuse me, I'm still sick, ladies and gentlemen, it's true. I did not recover much over the weekend, unfortunately. Then when I run this, I should be able to kind of go in here, take a look at that output stream, and do my escape key. Well, that did not work particularly well, to say the least. Why is my escape key not working? Oh, that looks like it didn't compile. What happened there? Why am I... How did that happen? I thought I compiled it, and yet it was still printing out W, which we deleted. So I guess I didn't compile? I don't know what happened there. That clearly looks like I compiled. Maybe I did something else wrong. There it goes. Yeah, I don't know. Ladies and gentlemen, programming. It's always a little wonky. Okay. So I hold it down. It is down, and it was down. That's correct. So I am getting key repeat messages, so I get them repeatedly. Then when I let go, I get just was down, and that's correct. Yeah. Perfect. So, looks like that's all good. Basically, we have everything we need here. We don't need those key repeat messages. So one thing that we could do if we wanted to is we could just kind of get rid of them. We could basically say that if was down equals to is down, this is not an interesting message for us, if that makes sense. We could just flat out say that. And then when we run in here, we will basically be eating those key repeats, right? Let's see, there we go. Is down, was down, no, oop. Did I do that the wrong way again? Yeah, awesome. I do that all the time, people. All the time. What I wanted to do was say if they're not equal. I wanted if it wasn't down and now it is, or if it is and if it was and then now it isn't. So I want them to be not equal. I basically filtered for the case we don't want. That's brilliant. That'll help a ton. Way to go. Good job. So there we go. That's what we wanted. Yeah, exactly. Perfect. So that's really all we want, and that is pretty much the entirety of key input as well. That's it. So we've got input now. We just need a game to funnel it to. And like I said, we don't want this. I mean, this is not good code that's going to do anything useful for us. I just want to put in there so you can show how to get at everything. Once we actually have something to fill out, what we'll be doing is in here, we'll just go ahead and say, okay, let's pass, let's fill out the stuff that we're going to pass to the game by using these things. So that's all we're going to do. Well, here we are at the 5-minute warning. We have already accomplished everything that I wanted to accomplish on that stream. Let me think if there's other things that I might want to do real quick. One thing I wanted to do is I got email from people over the weekend. This was supposed to be a win class A. Remember, I was trying specifically to make everything be A's where they should be. And so load library is also an A kind of a thing. So I'm going to try and go in here and just pass A to everything so that we know that we're not using Unicode for the benefit of people at home, just to make it a little easier for them if they're compiling in Unicode mode. Since we are not, if they are for some reason trying to do that, then this will make it a little easier on them, just if we have most of them correct. Okay, I guess get proc address only has an ANSI version. There is no Unicode version of that, so that's good. All right, that's all set. Let's take a look and see if there's anything else here that I wanted to take a look at. Yeah. So there is one more. One of the things I was thinking about over the weekend is and I asked some friends about it too, just to be sure. I decided I don't really like this passing by value. I mentioned it real quickly. I was talking about passing Win32 off-screen buffer by value, and really passing something by value in the hopes that it's going to optimize stuff when it's that big, when it's something that large, that is a fairly large struct. It's more than it's not like a tiny little struct. It's fairly sizable. I think in general you're counting on inlining. You're counting on the optimizer inlining this before it's really going to get a win out of that. And if it doesn't inline it, then it's going to be a problem because it's going to force copies and stuff like that. So I want to actually go back to the way I normally code. I kind of did that for the benefit of the people watching. But honestly, it's not something I would actually do. So I'm just going to go ahead and change it to the way that I actually do things and not try to be overly clever on the stream. I think that was a mistake. And so I'm just going to actually kind of rearrange the code here and just make it a little bit more like what I would normally do. And just because I think that's the right thing to stick to. I mean, I should stick to how I code. And if I want to mention something that other people do and say you could try to do this or investigate on your own, I think that's good. But I shouldn't try to do things that aren't the sort of things that I normally do just because they might be better or maybe they're newer ways of doing things. Because at the end of the day, I have no guarantee that they are actually correct, and I may just be leading you astray. So I'm going to go ahead and just clean that code up a little bit and make that look a little bit more like what I would have expected. Okay, so we are almost done with that. There we go. And now we are compiling again. And I think that is it. We are still in good shape here. We've got 3 minutes. I don't know what else we should try to throw in here in the 3 minutes. I guess one thing we could do is we could go take a look at the set cursor situation. Since we're still not setting the cursor, we could try to throw full screen in there 2 minutes. I don't know. 2 minutes. Maybe we just go to Q&A early. Maybe we just say that was a good day. We got everything done that we wanted to get done. We've got input in, and so we'll have the rest of the week to work on sound, which is really the only thing. Well, we got two things really: sound and file I/O. So if we can get through sound in 3 days, we could do file I/O on Friday, and then we would pretty much be ready to get going on the game proper the following week, which would be great. 2 weeks on Windows is not very much to spend. I mean, that is longer oftentimes. That is shorter oftentimes than it takes to figure out why your CSS isn't working when you're trying to make a web page. So I think that's probably pretty good. All right, I will go ahead and go to the stream now to see what is going on over there.
All right. I think simple enough. Just gotta handle keys. And then the last I did. Where is it? Yeah, I think I can. Oops, let's run it. Right now I can't tell what key gets pressed. Okay. So what is that event? Key press. Maybe there is a event type. Key press. Oh yeah, here. Why is that an X and Y? State and key code. Alright. That looks useful. Oh, no, I don't really need to break. A code. And then what else was there? State. Event dot x key event. What was it called again? X key. Dot key code. Event dot x key dot key state. Gonna be a bunch of numbers, not gonna make a lot of sense, but okay. This is WASD. State is always 0. Wonder if it's the input output state. Let me check. X. Seems like I don't need to grab keyboard. Slip. Sounds a bit quiet. See if I. Oh, it's logged out. That's weird. Okay. Events and types. Key release. Yeah, can listen to that too. Dot should be W. What's the second one? Oh, because I can't tell the difference. The press, and then we'll call it release. Okay, cool. Only gets triggered if I hold it down. If I press it once, nothing happens. Okay. Point to motion. I want to know what this state is. Guessing this is mouse stuff. Keyboard encoding. The W. No, it's not. So I don't know what that key code is. Is set to a special number that represents the physical key on the keyboard. The key code is an arbitrary representation of any key on the keyboard. Physical or logical key in the range of 8 to 255. Code geometry, blah 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 blah. Key symbol. Is that a key symbol? On this one. Maybe I gotta get it. The set of defined key symbols includes ISO, blah blah blah. A lot of that. Okay, okay. X11 / key symbol. How do I get a symbol? A list of key symbols associated with each key code. Founding K, blah blah. Okay, no symbol. an explicit word symbol, blah blah. Key press event is to make use of group 1, blah blah. Which group is it to my modifier state? Controller, blah, xk, numlock. To obtain the legal key codes for a display use. Not sure what this is. Let me go back to the event. Mentioned in this section of this. What's the utility function? Mapping between key codes and key symbols classifies as key sims and mapping between and string names. First three functions in this section operate on a cached copy of a server keyboard mapping. Given in keyboard encoding. Look up key symbol. X key event and what's the index? Does it return? Not sure what the index is. Specifies the index into the keysims list for the event's key code. What is key symbol? Is an encoding of a symbol on the cap of a key. Oh, okay. I did read about this. What else does it say? Do I have to do all of that? Display, window, time, root, state, key code. Okay, let's try and use this. X, look up key symbol. What is the type? I just put any. Key code. Key symbol. Event.key code. Well, I leave the index 0. Don't know what that is. What's that now? Okay. X key. get. Oh, hang on. I think I made a mistake. Don't need that. Don't need that for now. Jeez. What did I do? Segmentation fault at address. Blah. Okay. Now I wonder. I have no idea why that failed. Hang on. This is wrong. CT should be event dot key event. X key. Is that it? Oh no, not that one. It needs a C pointer to X key event. Okay. I don't think that's a C pointer though. Symbol one. Oh geez, this is like a lot of work. I gotta find out. Okay, it's the ASCII symbol. Because that's A. Ooh, that's shift. Capital A is the same. I know. Key symbol is equal to at switch press A. Okay, see, so well, else break. Oops. Always forget that. Too few arguments. Is the index. No. Where is it? Oh, I know. I think it's this one. I don't need this. Okay, there we go. Got A. Nice. That wasn't too bad. Do W S and then D and F. mean, I think that should just work. Okay. Then I'll handle it later. I think this is the same. I'll leave this as a to do. Not sure what to do with this. And okay, I need the escape key. I did return a number for shift. X11 key symbol. Okay. XK space. Can I do SimDef? Okay, small s. It's not linked though. Maybe I don't need it. Maybe I do. There should be another way to do it. And the debug document key symbol. guess space is just... Can I do that? I guess just add a space. Okay, space works. I don't know what to do with this number though. Don't think escape. I know, yeah, it's quite big. The number. I mean, I could just save that number. There must be a way to look up if it's space. Let me ask Cloud. And I get a key symbol on key press. It's 11. How can I differentiate the escape? Okay. Yes, I could add that. Key symbol. Here. Do xk space. Okay. It's got a weird naming system. Okay, brilliant. That was not too bad. So it prints the escape key as well. And key release. Yeah, not sure what to do with it. Can handle it when I need it. XK. Okay, guess I can just use WASD. Wait a minute, there's no XK. That's weird. Oh no, that is A B C D E F G H. Seems to have all of it. Okay, it's access. Okay, there we go. Whoops. I guess that's everything. I wonder if there's a way to know if the same to do. Check if this key works. Damn. I don't know. Not sure. Okay, I think I'll leave it there. That sounds good enough. Almost as much as Case did it. Almost. Minus the gamepad. Yeah, I think that's it. At this point. No, a press. Okay, I think that's good enough. Call it a day there and head to the gym soon. Okay, thank you for hanging out. I'll see you back here tomorrow. Hope you have a good day, whatever's left of it.